You've probably seen the headlines by now, and if even half of them are true, then what NASA just found on Mars may be the most important discovery in the entire history of humanity. Not a new planet, not a new star, something far more dangerous to our worldview, something that doesn't belong on a dead planet. Because according to NASA's own instruments, something inside a rock on Mars is behaving the way life behaves. And not in a poetic way, in a chemical way. The strange part isn't what they found, it's how quiet NASA is about it. Not the kind of noise you expect when you're about to flip human history upside down. Because whatever Perseverance found is either the most powerful evidence for alien life we've ever recorded, or another crushing false alarm like the ones that came before it. In February of 2021, NASA's Perseverance rover touched down inside Jezero Crater, a region no one picked randomly. This wasn't a scenic tour. This was forensic work. Jezero was once a lake, not a puddle. A real body of water with rivers feeding into it, sediment building up over millions of years, and chemistry that once would have been friendly to microbial life. Perseverance was sent on one mission: hunt for ancient life, not in the form of bones or fossils, but in chemistry, in scars left behind inside rock, in mineral fingerprints that only make sense if something once lived there. And for more than 3 years, nothing seemed out of the ordinary, until one day, it wasn't nothing anymore. While exploring the edges of an ancient river channel called Neretva Vallis, Perseverance aimed its instruments at a rock from a formation nicknamed Bright Angel. The rock itself didn't look dramatic, just another piece of Martian debris. But when PIXL and Sherlock scanned it, everything changed. Perseverance went quiet, then nervous, then excited. What it saw inside that rock should not have been there. The stone, later named Cheyava Falls, was laced with tiny black rings and specks. Patterns, not chaos. Shapes, not stains. The team affectionately nicknamed them leopard spots and poppy seeds. Each one measured no bigger than a grain of sand, but together, they rattled the entire field of astrobiology. The spots weren't random, they weren't cracks, and they weren't the kind of markings you'd expect from standard Martian erosion. They were organized. Even stranger, the chemistry inside them was wrong for a lifeless world. Perseverance detected organic compounds essential to biology: carbon, phosphorus, iron, not scattered wildly, but arranged in a way that made scientists go silent. Because on Earth, when you see carbon, phosphorus, water exposure, and iron behaving like this in a sedimentary rock, you don't usually call it geology. You call it life. On our own planet, certain bacteria don't breathe oxygen. They feed on iron. They live deep underground, in toxic environments. In complete darkness, they eat iron minerals and leave behind altered chemistry where they passed by, like fingerprints, and the leopard spots were showing the same damage. The lighter part of each ring matched the surrounding rock, but the darker outer rims were chemically rich with iron and phosphorus. That kind of pattern usually means something removed iron from one place and deposited it in another. On Earth, microbes do exactly that. And when astrobiologists saw this, their excitement spiked. Years of study, decades of false hope, and suddenly, Mars was whispering a familiar language. But hope is dangerous in science, because if there's one thing researchers know, it's that Mars has lied before. So immediately, they tried to destroy the idea. They went hunting for any explanation that did not involve biology. The first suspect was heat. Maybe this was volcanic chemistry. Mars used to be violent. Lava could explain strange reactions, right? No, there were no volcanoes nearby, no tectonic leftovers, no ancient heat signatures strong enough to force these reactions. For volcanic chemistry to work, isotopes would need to migrate from a hot zone into a cold one, across distances that don't make sense. Scratched. Then they tried pressure and temperature. Could underground heat cook the chemistry into this shape? Again, no. For sulfate to reduce into the mineral greigite, temperatures would need to exceed 150 degrees Celsius. But everything around Cheyava Falls pointed to a calm, low-energy environment. No thermal scars, no baked rock, no transitions, just quiet sediment. Then they tried acidity. Maybe Mars used to be acidic. Acid dissolves minerals faster. Acid could mimic biology, right? And that idea almost worked, until Perseverance found a green mineral nearby, olivine. And the moment that happened, that theory collapsed. Because olivine cannot exist in acidic water for long. It dissolves faster than nearly any other mineral. If the environment had been acidic, olivine would be dust by now. But there it was, still intact, which meant the water was neutral, not corrosive, not violent, gentle. And when you combine neutral water, clay sediments, organic molecules, iron reduction, and rhythmic mineral patterns, chemistry starts looking like something else. At this point, the team focused on two minerals, vivianite and greigite. Vivianite forms when microbes digest iron and release byproducts into a watery environment. Greigite forms when microorganisms break sulfate into sulfide. On Earth, these minerals appear almost exclusively where life is present. Not 100%, but close enough to make grown scientists whisper. And suddenly, there were no easy outs left. No volcanoes, no acid, no heat, no chemistry model that made sense, which left only two explanations. Either Mars has a type of geology no one has ever seen before, or something lived here that used chemistry the way life does. Now, if this sounds familiar, it should, because this isn't the first time Mars tricked us. Back in 1976, NASA's Viking lander thought it found alien life by injecting nutrients into Martian soil. The results set off alarms. Gas was released. Metabolism seemed active. The world held its breath. Then decades later, they realized the soil contained perchlorates, a harsh oxidizer. It created chemical reactions that faked life. False positive. In 1996, a Martian meteorite showed shapes that looked like bacteria. Even the president made an announcement. Later, geology again. False positive. And because of those moments, NASA does not celebrate early. They whisper, they hesitate, which makes this discovery unsettling. Because NASA still hasn't ruled it out. They published the data, the numbers, the possibility, but they did not declare it. Which means something about this is harder to kill than usual. And for the first time in decades, Mars isn't whispering silence. It's whispering history. NASA didn't rush this discovery to the world. And that alone said more than any press conference ever could. Because when NASA is confident, they celebrate. When NASA is uncertain, they delay. But when NASA is scared, they whisper. And this time, they whispered. The research team didn't announce life. They didn't use the word even once. Instead, they did something far more telling. They tried to disprove it. The official paper that followed didn't aim to prove anything was alive. It aimed to prove that nothing was. Scientists started with one goal: destroy every theory involving biology. Disqualify microbes. Eliminate habitability. Shatter the fantasy. That's how real science works, not by proving something is true, but by proving every other option false. And over months of analysis, they failed. Not because they didn't try hard enough, but because the chemistry wouldn't obey. Every non-living explanation collapsed under the weight of lab modeling. The mineral structures resisted simulations. The chemical ratios didn't align with volcanic theories. The iron distribution didn't match geological predictions. All roads led back to the same uncomfortable door, and behind it was biology. Still, NASA refused to call it, because if there's one lesson Mars has taught us, it's patience. Back in 1970s, the Viking landers conducted the first real biological experiment on another planet. That mission changed everything overnight. Martian soil reacted to nutrients exactly like living microbes do. The reaction was immediate: gas release, chemical activity, signatures that, on Earth, would have passed as proof of life. Scientists declared it, then regretted it. In 2008, the Phoenix lander found perchlorates in Martian soil reactive salts that mimic biological reactions when heated. The life signal Viking detected decades earlier was just aggressive chemistry. The dream collapsed, just physics doing what it always does. Mars humiliated us twice. NASA learned. So this time, they didn't announce. They prepared. Because this wasn't data you release lightly. This wasn't a press headline. This was existential. NASA created something called the Confidence of Life Detection Scale, a way to measure how close any discovery actually is to confirming biological activity. It ranges from, "This could be caused by life," to, "Independent teams have proven life more than once. I can't really." Right now, this discovery sits somewhere between level 3 and 4. Intriguing, uncomfortable, unfinished, but close enough to make the entire scientific community stare, fixated, because the next step is impossible to fake. Earth. The only way forward now is to bring that rock home. Literally, NASA and the European Space Agency built an entire mission around this possibility. The Mars Sample Return. 3 spacecraft. 1 to land, 1 to launch, 1 to catch. Perseverance already did its part. It drilled into Cheyava Falls and extracted a pristine core sample from within the rock. A piece scientists named Sapphire Canyon. Right now, that sample is sitting on Mars, ready to rewrite biology or destroy decades of hope. But the mission stalled, delayed, suspended. The price tag ballooned to $11 billion. Politics turned bitter, budgets clashed, timelines collapsed. What was supposed to launch by 2033 is now pushed beyond 2040 with no guarantee it ever resumes. And yet, every decade, the world's leading scientists rank this mission as NASA's single most important priority, twice in a row. Why? Because once that sample reaches Earth, there is no room for guessing. In Earth laboratories, scientists will run 2 tests that life cannot hide from. The first is chirality. Life on Earth prefers one direction, left-handed amino acids. Non-living chemistry doesn't care. If that Martian rock shows preference, it's not random, it's biological. The second test is carbon bias. Life cheats chemistry. It favors certain isotopes. Carbon-12 is lighter than carbon-13. Life prefers it. Rocks don't. If Sapphire Canyon shows imbalance, then Earth won't just study Mars. Earth will confront it. And whatever the truth is, it will not be subtle. NASA knows this, which is why they're not celebrating. Because once the sample lands, history either updates permanently or collapses quietly. But let's imagine, just once, what if it's real? What if those patterns are alive, or were? Then Mars wasn't dead. It was dormant. It had chemistry like Earth, water like Earth, time like Earth, which raises the first terrifying question. Who came first? Earth or Mars? Did life begin here or travel here? Did a meteor carry our ancestors between worlds? Or did biology ignite twice by accident on neighboring planets? And if that can happen twice, why not 1,000 times? This rewrites the Drake equation, the formula used to estimate extraterrestrial civilizations. One of its key variables is the probability of life appearing on a habitable planet. Right now, we only know of one example, Earth. If Mars becomes the second, that variable explodes towards certainty, because life no longer becomes rare. It becomes inevitable, which introduces a terrifyingly simple concept, the 0-1 infinity rule. Either life exists nowhere, one place, or everywhere. We already know it's not 0. If Mars is 1, we're alone, a single flame in infinite dark. But if Mars makes it 2, then 2 becomes 10, 10 becomes 1,000,000, and suddenly, we're not unique, we're not rare, we're not special, and for the first time, the universe feels crowded, or worse, empty by design. But here's the strangest part. Even if this isn't life, it still matters, because Mars is a time capsule. Earth erases its own history. Volcanoes melt it, oceans swallow it, plates crush it. But Mars kept everything, frozen, billions of years untouched. Studying Mars is time travel. It's looking at Earth before Earth became alive. And in doing that, we're not just searching for aliens, we're searching for ourselves. And one day, whether in 10 years or 50, a capsule will land on Earth. Inside it, a rock no bigger than your palm. And inside that rock could be the answer humanity has asked since it first looked up. Are we a miracle or a pattern? Are we alone or late? And whatever that answer is, it will not just change astronomy. It will change meaning. It will change belief. It will change identity. Because once the universe answers us, it never takes the answer back. And this time, it's finally answering.